greater than y. I can say probability of x less than y. I can say, so when I say probability of x greater than y, maybe I'm trying to say x is more reliable than y, particularly in engineering, okay, where we talk about the stress and strength model. X represents, the stress applied. When you apply stress, okay, and y is the strength of the system. If I want to find reliability, I basically need to find the probability of x greater than y. I'm going to take you into politics now. In the other time, I told you x represents maybe the proportion of votes received by a particular political party, maybe in 2020, and y represents the percentage of votes received by that same party in 2022 election. Do you know we may want to find what is the probability that the percentage of votes received by that particular party in 2020 would be greater than 2022. We can also use the idea of probability of S greater than Y. Let me also tell you, this is also used in medicine. Okay, we use it in medical field. Okay, give me 1 second. Now, in medical field, where we're talking about the survivor analysis, okay, maybe you actually have two different treatments, two different kind of treatments. Maybe here you use chemotherapy on patients, maybe patient with cancer, and maybe here you use physiotherapy. Okay, maybe the combination of physiotherapy and chemotherapy. Okay, now you have some patients, you use this on some patient, you use this on some patient, and you now want to compare survivor times on average. If you do the probability of S greater than Y, you know what you're trying to say. What is the probability that those who actually receive chemotherapy, they're basically going to live, they're going to have more survivor time than those who receive this. Does that make sense? So that idea is also used in medicine. Now, you understand that? Okay, go ahead. Oh, this one is, in engineering or in physics generally, I don't know whether you've heard about Hooke's law. Hooke's law. I'm not in physics, but have you heard about this? Hooke's law. When they say when you apply a force, when you have an elastic material, right? You stretch it, right? What are you doing? You stress it, you're applying a force, right? And they're going to say it's going to get to a point. This thing is going to break when you reach a breaking point, right? The force, depends, on maybe, the way it's going to stretch depend on the force you apply. Now, when you are talking about when S is a stress, like a force applied, right? Okay, and Y is the strength, right? Okay, if you want to find the probability of S greater than Y, okay, then you are actually talking about stress, talking about strength model. It's like you're looking at the relationship between the stress that you apply and the strength. Does that make sense, right? So that is physics. And that was why I tried to go by way of, because this is where it started, but the application is now wide. I just use this in politics now. Okay. Oh, I remember in this class, I gave an example of percentage of customers who use a drive-in facility in a bank and percentage of customers who use a walk-in, right? Now, what if we want to find the probability? What is the probability that the proportion of customers who walk in will be greater than who drive in. This is also applicable. Does that make sense? Okay. Now, how do we get that in discrete? When you have a discrete function, take a look at this guy now. That's a discrete function. Oh, in this class, I've been giving you table for discrete, right? Y for continuous, I've been kind of, giving you, what is it called? A function. We can also have function for discrete. Take a look at this guy. P x of y is a joint, it's a discrete joint, okay, which we call a joint PMF. The state space of x is 1 to 2. The state space of y is 1 to 4. Okay, please, I need you to pay more attention to this. If you see the midterm practice that I gave you, is basically going to follow the trend. Does that make sense? Or even though, of course, before the midterm exam, we're going to dedicate a class where I'm going to review the practice question with you. Does that make sense? Okay, now look at the state space of x and the state space of y. You know what it wants to find? Find the probability that y is greater than s. Do you know that the probability of y greater than s is the same as the probability of x less than y? So it's the same. If y is greater than s, then you mean s less than y. Does that make sense? Okay. Now, they also wanted to get a marginal for x, the marginal for y, and at the same time, they can ask you to investigate for independent. Now, do you know that with that, you can generate a table, okay, where you're going to plug in, 2 level by 4 level. That would be what? 2 times 4 is 8, right? You're going to have 8 cells, okay? You're going to have that guy. Any question? Or now I put that table in place, okay? So which means the table that you've been having, okay, when you are working with a discrete, we actually simulate, the values of the table using function. This is one of the function. Now, do you know I can find the probability of y greater than s? You need to first set up your table. Y greater than s. Now, when you see 1, 2, the very first value that you are seeing is for x. Okay? 1, 2, it means s equal to 1, y equal to 2. In that situation, y is greater than x. Now, take a look at every other possibility. That is a possibility. Any question on how I figure out y greater than s? This is the same as x less than y. Isn't it? That's another way to put it. Okay. Then I'm just going to go to the table. I'm just going to take the corresponding probability value. I'm going to add them up, and that will give me 23 over 32. Is there anyone who need more clarification on that? That's super easy, right? Okay. Now, how I want to get the P of x? You got to get P of x now. Okay. You just basically, if you take a look at x, 1, 2, right? You're basically going to have 2 values for P of x. Okay, 2 values for P of x. Don't forget, what is the state space of x? 1 and 2, right? Okay, for marginal for x, you need when s equal to 1. What is that? That is 7 over 16, right? When s equal to 2, 9 over 16. So how many values that do you get? Depending when you are working with discrete and you basically want to figure out the marginal, that depends on the state space. Then the marginal for y is going to be 4 in number. Look at that. 5 over 32, 7 over 32, 9 over 32, 11 over 32. Does that make sense to everyone? That's how that is done. Now, finding the probability of s greater than y. Oh, go ahead. Oh, okay. Now, this is the situation. I just work my marginal now using the table. If you want to go by, give me 1 second, what I gave you the other time. Now, if I want to find marginal, is basically I'm actually going to sum this guy over the range. of y. What is the range of y? 1 to 4. Do you remember that? Now, but getting my marginal for x for discrete, I also need to consider the state space. The state space s equal to 1, s equal to 2. Let's assume I want to do that now for x equal to 1, right? And I'm actually going to do this to 4. The function is x plus y over 32. So which means I'm going to be plugging in. Look at what I'm going to do. If I want to get it in terms of expression, x plus, what is the range? Okay, x plus 1 over 32, x plus 2 over 32, okay, x plus 3 over 32, x plus 4 over 32. You see that? Okay, now if you take a look at what I'm doing here, adding x plus 1 over 32, x plus 5 over 32, you know, this one is a situation where I'm just generalizing for x. So generalizing for s, it means I'm going to have it in terms of expression. So this is basically going to be 1, 2, 3, 4, 4x plus 3, 6, 10, right? Over 32. Now, this p of x now, if I now want to find what is the p of x equal to 1, p of x equal to 2, all what I just need is to come here and plug in 1 and 2, then I'm going to get 2 values. That was what I was trying to say. You see, 7 over 16. Let's see. Let's plug in. When s equal to 1, 4 into 1 plus 10, right, over 32, that would be what? 14 over 32. That would be 7 over 16. You see that Italian with a, any question? Oh, okay. Now, the next thing I actually want to do now, you know, it's going to be super easy when you're working with, discrete. If you're working with continuous, okay, take a look at this guy now. This is a continuous, right? S plus 4y, and the range of y in the range of s is specified. And here they wanted to find the probability of s greater than 4y. You know, it is not only s greater than y. Here is like we can do s greater than 4 times the other variable, or 3 times the other variable. Now, since you are working, you know, anytime we actually talk about days, whether greater than or less than, of course, you're actually going to use two integral sign. Okay. Now, when you use two integral sign, it means you're actually going to integrate the function respect to x, respect to y. How are you going to decide on, you know, one? Now, let's have, if you take a look at what I have, let's first decide on the range of x. If you take a look at that, 0, I'm going to first start with 0 to 1. If I want to decide on the range of y, I will solve that. Okay, let me show you how you're going to solve this guy now. Okay, so you know I have s greater than 4y. Okay, and I need to solve for y if I want to determine the range of y. Okay, now you know this is going to be over 4. If you divide both sides by 4, give me 1 second. I'm sorry that this is on. Okay, so now this is going to be x over 4 greater than y. I mean, sorry, greater than y, right? Okay, if you have x over 4 greater than y, what if I want to, if I switch that, it's going to be this, right? Now, if I want to decide now, I have to, you know, y less than this means I'm going to start from, I'm going to come from the lower part and end up in x over 4. You see, that was why is 0 to x over 4. Does that make sense? That is the way you basically going to figure it out. So you integrate 4 with respect to y, you plug in that respect to x, then your final answer is going to be 1 over 8. Is that taken, right? Okay, now I want to go to the next one. Of course, getting f of x, marginal, is going to be super easy. For marginal, let me tell you this. If you want to get for marginal, you look at the range of y, the way it appears. what is the range of y? 0 to x. That was why you see this. That was why it's 0 to x, right? If you want to get the f of y, the range of x. The range of x, look at that. X lie between y and 1. Okay? And that is why, that is what you see now. Of course, if anybody has a question, are x and y independent? If I multiply f of x by f of y, if it gives the joint, you know the joint, what is the joint? S plus 4y. I'm actually going to say x and y are independent, and y they are not. Okay, now if not find the covariance, not for this week. You know, next week we're going to start mathematical expectation. That is where we're going to talk about covariance and the like. Oh my God, take a look at this question. You know, when you look at the textbook very well, ask a lot of practice question in the textbook. Now, find the probability of y greater than 0.4, given that x less than 0.8. Anytime you have a function like this, you are going to use conditional probability function because it's a dimension given. Look at that. It means you need f of y given x. And don't forget the f of y, the f of y given s, f of y given s is the joint divided by f of x. You know that, right? Now, of course, you know, that follows from the idea of a conditional probability. Okay, that follows from the idea. Now, you want to find the probability of b. The probability of b is more or less like, oh, I want to figure out f of x. And if you want to figure out f of x, s less than 0.8. If s less than 0.8, then you go to the lower part to 0.8. Okay, the lower part of x is 0. Then you're going to end up in 0.8. You get your answer. Now, how do you now, you know, you want to find f of x, y, but in the question they did not give you f of x, y. Okay, you know, if you want to find, sorry, you are given f of x, y, you are given x plus 4y, but you need to be able to combine the range so that you'll be able to get the point of interception, okay, the common point between the range. Now, take a look at that. You know, that was why I want to find, y greater than 0.4 interception, okay, intersection x less than 0.8 is more or less like I'm doing A intersection B. Don't forget. So this is similar to, A given B, which is equal to the A intersection B divided by probability of B. So the probability of B is like more or less like that. This is more or less like that. So why do you need this guy? You actually need to bring out what the state space is actually going to look like. Now, when you have that, the range of S is going to be from 0.4 to 0.8. Why do I know it's from 0.4 to 0.8? Because S less than 0.8, that would be the highest. Then I'm just going to be coming from 0.4, the other one. Then the range of Y, of course, why do I have the range of Y to be that? Because the probability of Y greater than this means it's going to start from that to up. And that was why you see 0.4 to 0.8. So when you get that, you get that now, then you divide, you have your final answer. Any question? Go ahead. What? Why is it lower bound of x? Of course, look, initially, look at how s less than 0.8. The highest value s can be is less than 0.8. Yeah. Why is it lower? Why is the lower bound for x? No, the lower bound for s is 0.4. I mean, if you take a look at this, the lower bound, I'm going to show you something. there's this point interception law. Okay, you know, when we're talking about interception law, you are looking at, look at here, you are looking at what do you have at the point of intersection between when y is that value and s is that value, and putting into consideration. Don't forget, you have to put into that arrangement. Look at that arrangement: 0 less than y less than s less than 1. I understand what you mean. If that is not there, I understand your argument. So you have to put that into consideration. Okay, now you're done with that. Of course, this is going to be super easy. You're given this, and you want to find constant. You know, if you watch my video, that will be super easy. Okay, we also have situation where we need to do some derivation. How do I find, look at that, the probability of x plus y less than 1? Okay, the very first thing you're basically going to do, you go back to the arrangement, the state space. The state space of y is from 0 to root of x. Okay, when I want to solve inequality, I'll first assume equality when I want to solve inequality. Okay, now I'll first say, okay, let y be equal to root of x. If y equal to root of x, then from this arrangement, x plus y less than 1, if I convert that inequality to equality, then y will be equal to 1 minus x. You understand that, right? Now we have, if y equal to that and y equal to that, I'm going to solve for x. Solving for x give us y squared. Another x give us 1 minus y. Then we're going to equate that. Okay, so you're going to do, you know, since x equal to y squared and s equal to 1 minus y. Okay, so then you can do y squared equal to 1 minus y, so that you're going to have this equal to 0, leading to quadratic equation. Okay, leading to quadratic equation, then you're going to have 2 values. Okay, now but you're going to take the positive 1, right? That is what you're going to use as the range. Look at that. So it's 0. The range of y will be from 0 to that guy, and the range of s is y squared to that. So when you, so that will be super easy. The final answer is going to be this. You know, if you don't get it, meet with me during my office hour. Now, lastly today, I want to go into permutation and combination. Oh my God, this is my favorite topic. Go ahead. Okay. No, you're going to use calculator. In fact, that's a good question. During you know, I said we're going to have a practice question together, right? By practice session, I'm going to tell you what and what you need for the exam. I will allow calculator.